Hello everyone, welcome back to Exam Ignite YouTube channel. Today I am continuing the Module 3 Part 2 video of the Microcontroller BEC405A 4th semester 2022 scheme VTU. So here in this video, I'll be covering the serial communication part. So serial port programming. So in the serial data communication, the byte of the data must be converted into serial bits using what? A parallel in serial out shift register, and then only it can be transmitted over a single data line. So at the receiving end, there must be a serial in parallel out to get back the receive the data, serial data, and then pack them back into a byte. So example, if a data is transmitted to a telephone line, so it must be converted for what? Zeros and ones to audio lines, which is our sinusoidal shaped signals. This conversion is performed with a peripheral device called a modem. This is an example. So here we are having two methods. One is synchronous and the another one is asynchronous. Synchronous with a block of data and asynchronous a byte of data. So let us explain the simplex, half duplex and full duplex. So here half duplex is asked in the model question paper 1. Simplex means its communication is unidirectional. That is, data flows in only one direction. Here one device is always the sender and the other one is receiver. Example is television. Half duplex means it is bidirectional. That is, but only one direction at a time. Only one. Both the devices can send and receive but not simultaneously. Example is walkie-talkie. Then comes full duplex. It's a communication. This is also bidirectional and simultaneous. Both the devices send and receive at the same time. So you can observe here through the block diagram, transmitter, receiver. Here half duplex, transmitter and receiver. Here receiver and transmitter. These are not synchronous. Here transmitter to receiver and from receiver transmitter to receiver. Principle of this operation of the asynchronous serial communication. It is widely used in the character-oriented transmission. Here each character is placed between the start and the stop bits, called the framing. That is, ASCII characters are packed between the two start bit and the stop bit. The start bit is always a 1 bit and a stop bit can be 1 or 2 bits. So start bit is always what? Low. Stop bit is always high, which is referred to as a mark. So 0 is low, it is referred to as a space. In the example, ASCII, that is character A, is framed between the start and the stop bit. The transmission begins with the start bit and it is followed by D, which is a LSB. Then the rest of the bits until the MSB, that is D7. And finally, the one stop bit indicating the end of the character A. If the ASCII character having a one stop and one start bit in a frame, it gives a 20% overhead. That is, a character has 8 bits with the 2 additional bits. So the rate of the data transfers in the serial communication is started in bits per second and baud rate in the modern technology, which defines as number of signals that changes per second. Data rate depends on the communication port. Synchronous serial communication. This is a type of serial communication where the transmitter and the receiver share a common clock cycle. So the data is transmitted in sync with the clock. When 8051 is operated in the mode 0, it works as a sync serial communicator with 8-bit shift register mode. Data is transmitted and received bit by bit using the TXT, that is transmitter of the output, and RXT for the input. Next is RS-232, an important topic. You need to know the connections and you need to write a short note on that. It is a 9-pin DP connector. So RS-232 is a recommended standard 232, widely used for the serial input-output interfacing standard. So voltage level, it is logic 1 means -3 to -25, logic 0 means +3 to +25. To connect this RS-232 to a microcontroller, we must use a voltage converters. That we are using here is Max 232. This will convert the TTL logic levels to the RS-232 voltage levels and vice versa. The IBM introduced the DB9 connector, which is a serial input-output standards. This is our pin connector. Figure here it is shown. So this here, the first pin, it is having what? Data carrier detector. 2 is having receiver data. 3 is having transmitted data. Next, data terminal ready. Then signal ground, data set ready, request to send, clear to send, then ring indicator. This is our RS-232 connected DP25. We have only DP9. So examining this handshaking signals of the RS-232, the data communication equipment is classified into two categories. One is DTE and DCE. DTE means data terminal equipment. This refers to the terminal that send and receive the data, example computer. Data communication equipment, it refers to communication equipment responsible for transmitting the data, that is modems. You can observe here this is a null modem connection and the handshaking signals, how DTE and DCE connected. DTR, it is a data terminal ready, where the terminal is turned on and it sends out the signal to DTR to indicate that it is ready for communication. DSR is data set ready. This is turned on when it has gone through the self-test, that is, it has asserts DSR to indicate that it is ready to communicate. It is an output from the modem and input from PC. RTS is a request to send active low that indicate the byte of the data from DC, that is DTE, to transmit the modem. CTS, clear to send. In response to the RTS, when modem has a room for storing the data, it sends out the CTS to DTE to indicate that it can receive data now. DCD, it is a carrier detect. The modems assert a signal, that is DCD, to inform that a valid carrier has been detected that connects between them. RI is ring indicator. It is an output from the modem and input to PC that indicates the telephone is ringing. 8051 connection to RS-232. It has two pins. One is RXT P3.0 and TXT P3.0 and RXT P3.1 for transmitting and receiving. TTL is compatible because they require a line driver to make them RS-232 capable. That is, a MAX 232 and MAX 233 level connector uses the +5 power sources. So you can observe here, our MAX this 232 has two sets of line drivers, transferring the data and receiving. The line driver uses TXT at T1 and T2, while the line driver used for RXT are R1 and R2. T1 and R1 are used together. TXT and RXT of 8051. R2 and T2 are used for TXT and RXT of 8051. This is how the connection is made. Next comes the SCON register. This is an 8-bit register. This is used to program the start bit and stop bit and data bit of the data framing. That is SM0, SM1, SM2, REN, TB8, RB8, TI, and R. SM0 is a serial port mode specifier. SM1 is a serial port mode specifier. Then SM2 is used for the multiprocessor communication. REN is a set or cleared by the SPW to enable or disable the reception. These two are not widely used. T1 is transmit the interrupt flag that is set by that at the beginning of the stop bit in the mode 1, and it must be cleared by SPW. So in the receiver, here it is receives the interrupt flag by the HW, that is halfway through the stop bit time in the mode 1 and must be cleared by SW. So if it is 00, then it is serial mode 0, which is synchronous, is 01, mode 1, 8-bit, 1 stop bit and 1 start bit, 10, mode 2, 11 means mode 3. SM2 is D5 bit, enables the multiprocessor compatibility of the 8051. REN is D4 bit that receives enables on the RXT. If REN is 1, REN is 0, receiver disable. In RB is 8, it is used for the serial mode 2 and 3 during the transmission. In the serial mode 1, these bit get a copy of stop bit when an 8-bit data is received. TI means when the 8051 finishes the transfer of the 8-bit character, it raises an TI flag that indicates that it is ready to transfer the another bit. TI bit is raised at the beginning of the stop bit. RI means when the 8051 receives the data serially by RXT, it gets rid of the start and stop bits and places the byte in the SBUF register. Then it raises the RI flag to indicate that byte has been received and should be picked up before it is lost. Here is a program XTAL is given. TH value that is needed for the baud rates we have to find out. So that must be first divided by 12. After dividing it by 12, divide that by 32. So here we get a 28,800 Hertz in the frequency that provides a UART to timer 1 to set the baud rate. That is 28,800 divided by 3, that is 9600, where minus 3 is equal to FT hexadecimal, it is loaded into TH1. Similarly, divided by 12 and divided by 24. And the main important program, you have to write a C program to transfer the message. Yes, serially at a 9600 baud, 8-bit data, 1 stop bit, it has to come continuously. Firstly, write the header, that is hash include register 51.h, void serial transmitter, that is unsigned character, void main, consider a function void main, void. Then it starts TMOD is 0 cross 20, that is what it uses a timer 1, 8-bit auto reload. TH1 is 0 cross FT, that is 9600, FT is 9600 baud rate. SCON 0 cross 50, then TR is 1, that is start the timer. While 1 loop starts, that is serial transmitter Y, serial transmitter E, serial transmitter S. Next is void S serial transmitter, that is unsigned character. You have to define that now. SBUF is X, that is place the value in the buffer, while TI is equal to, that is equal to 0, wait until it is transmitted. Then TI is equal to 0. This is the what about the program. So this completes the module 3 completely. I hope you have understood everything, and please do note that the major important questions here is TCON, TMOD, then mode 1, mode 2, SCON, RS232. These are the main, and the program or any calculation part problems that I have done. So these are the main important topics in this module 3. To score well in this module, do watch all the videos and do like, share and subscribe with your subscribe the channel and share it with your friends. Thank you for watching.